Hi all, my name is Gulshan working as an assistant professor AI and DS department. So today, in the continuation of the unit 5, that is probabilistic reasoning, we are here with a new topic called probabilistic reasoning. Okay, so what is this probabilistic reasoning and how it is being resolved is using this Bayesian network. So what is this Bayesian networks? Okay, now a directed graph in which each node is annotated with quantitative probability information. That is, every graph will be given certain informations. In that given informations, you will be connected with the different kinds of possibilities, right? That is called as the Bayesian network. So each node corresponds to a random variable which may be discrete or continuous over here. Now a set of directed links or arrows, that is connected pairs of nodes, will be connected with the different variables. Okay. Now in this, a graph has no directed cycles. Each node has a conditional probability distribution that quantifies the effect of the parent of the node. Now see, in this the variables called toothache, cavity, catch and weather. In this, the weather is independent of all the other variables. Toothache, cavity are conditionally independent given with the cavity. So cavity is a direct use of toothache and catch, and no direction causes relationship exists between toothache and catch over here. So in the next example, we will be seeing a variable of burglary, earthquake, alarm, Mary calls and John calls. Okay. New burglary alarm installed is there is a new alarm which is installed at home, and it is fairly reliable at detecting a burglary. Okay, now it responds on occasions to minor earthquake. That alarm will respond to the minor earthquake, and there are two neighbors, that is John and Mary. They will be ringing up the alarm based on the earthquake that is being associated with it. Okay, John nearly always calls when he hears the alarm, but sometimes confuses the telephone ringing. Mary likes rather loud music and misses the alarm. Okay, when there is a possibility of doing this. Okay. Now in this, there's a graph which is given, that is all are associated with an alarm. Burglary and earthquake, which is directly affected the probability of alarms going off, and John and Mary call depends only on the alarm. Okay? The network represents our assumptions that they do not perceive burglaries directly, they not notice certain minor earthquakes, and they do not confer before calling them. Now in this, you have certain conditions, like how you will calculate it. It is based on the conditional probability table. Okay, in this conditional probability table, each row will be containing the conditional probability of each node or the values. The conditional case is a condition of values for a parent node, and each row must have a sum to 1. The entities represents the exhaustive set of causes for the variable. For the Boolean variable, the probability of a new true value is p, and for the negation value, that is false, it will be 1 minus p. Boolean variable will be denoted with k, and the parent of that Boolean value will be denoted with the 2k value. Okay. Node with the no parent has only one row representing the priority value, and for each values you will be given different kinds of values that is associated with it. So while calculating different values, so when John and Mary feel some earthquake, they will be giving certain alarm value which is associated with it, and for each and every nodes, that is John calls, Mary calls, you will be having the probability values that is associated, and based on that value you will be calculating the probability value. Say for example, if there is earthquake occurring, okay, now John also calls and Mary also calls, the probability will be both true and true, right? So the probability for both values will be around somewhere around 0.95. Now there is a statement called true and false. What is that? When you add both those values, you will be getting a probability of 0.94. Now false and true value, you will be getting 0.29. If both the values are false, you will be getting 0.001 value or something like that. So this is how you will be calculating the values, the probability values, and how it is being dealt. So in this video, we saw like how this probabilistic reasoning is being evaluated and what is the process that is evolved with it. The next upcoming videos we will see certain other topics that is correlated with this unit and how it is being developed. As of now, thank you and have a good day. Bye.